Hello everyone, very excited to be here. So let's begin by going over our usage of Temporal at DataDog. First, I'd like to start introducing how we use Temporal at DataDog, and for that, I will try to explain our other infrastructure at DataDog. So we have three main regions, US, Europe, and Japan, and we have many sites on each region. We use the three major cloud providers, so GCP, AWS, and Azure, and particularly AWS is probably our biggest one. And in addition to that, and just to throw some numbers over there, we have tens of thousands of Kubernetes nodes. We run hundreds of these clusters, and some of our clusters have over 4,000 nodes. And we do this in a self-managed way. That means we don't use the cloud provider Kubernetes offering. We have our own solution. So, really big infrastructure. We use all of this infrastructure to run Temporal, and we have, again, some numbers here. 60 plus unique Temporal clusters, and each of these clusters has its own Elasticsearch, its own Cassandra, and we also use buckets for archival and all of that. We have been using Temporal for over 4 years, so we have done migrations, we have done multiple Temporal versions, we have done experimental versions as well, and so on and so on. And we heavily use advanced features, so advanced visibility, archival, authorization and authentication, MTLS, and all of the other fancy stuff. Long story short, we are heavy users of Temporal, and we are advanced users of Temporal. We have all of this infrastructure to power 80 plus teams that are currently using Temporal at DataDog, and we have over 200 Temporal workers, so different Temporal workers running many different kinds of workflows. And we execute billions of actions per month. So these are not workflows or activities, these are state transitions, we can call them. So again, really big infrastructure, many Temporal clusters, advanced usage of Temporal. Over these 4 years, we have had many incidents, sadly. Too many to really summarize in a presentation, but we will still try. So the first one happened on March 2023. This was a global DataDog outage, so not good. And we internally call it the Aptocalypse, and you will probably understand the name a little bit better on the next slide. So this was an incident that resulted in a global DataDog outage. So DataDog is globally down, it's hard down. So I'm going to go over a quick summary of what happened here. So the initial cause was a security update in Ubuntu, specifically in systemd that everyone loves. This caused nodes, our Kubernetes nodes, to lose network connectivity. They became unhealthy, and this caused some very spectacular results. As a result, all of our regions were affected. So this automated process happened across all of our regions roughly at the same time. And just to throw some numbers your way, DataDog was hard down over all regions, and we had over 70 different Slack channels responding to this incident with approximately 400 engineers trying to fix the issue in real time. So, big incident, company-wide response. Let's begin by going over a timeline of this incident. It all started very early in the European morning. This is, for Central Europe, it's approximately 6, 7, depending on the country you're on. So this was very late in the US as well. So most folks were at bed or trying to go to bed or maybe waking up. An automated system triggered an update in Ubuntu. This was a fleet-wide update. It happened across all of our infrastructure at roughly the same time. It included a vulnerability fix. Inside these commits, we have this very innocent-looking message here. So, drop unnecessary routing policy rules. Those very loaded words, unnecessary, drop. You don't want to really hear that, right? So you can see in the description that this basically drops the network policies routes not created by networkd. This was an issue for us because we use internally Cilium for our Kubernetes networking. And Cilium uses these policies. So systemd dropped the unnecessary Cilium policies. Now, this automated upgrade happened across all of our nodes. And a few minutes later, we start seeing that nodes are unhealthy. They have no network. We can't ping them. We can't do anything to them. They start failing. Now, specifically on AWS, we have other cloud providers, but specifically on AWS, if your instance, if your node is unhealthy, AWS is super helpful, and it's going to say, okay, I can't reach that instance. It's part of an auto-scaling group. I'm going to go ahead and give you a brand new instance with a brand new disk just for you, because you're really nice. This was a big problem for us in hindsight. Why? Because this was a fleet-wide incident, so 60% of our nodes were affected. These are rough numbers. So in less than 1 hour, AWS, and I'm not putting the blame on AWS, gave us 60% of our nodes on brand new nodes, right? So this tries to illustrate what happened there. And you can see that in roughly an hour, thousands of our nodes were recycled. So new disk, new IP, brand new virtual machine. And the vast majority happened at the start of the incident. So update, nodes go down, these nodes are replaced, and then chaos ensues. Like, it's not good. One question is, what happens to systems like Cassandra if you lose 60% of your nodes in less than an hour? The answer is not great. You lose data. You can still maintain quorum, but you will lose data. Cassandra will try to move data around, but given the scale, 60% of our nodes down, and given just all the chaos, it was not able to move the data around fast enough to give us that durability. So we actually lost data in Cassandra. And we use Cassandra for Temporal, so Temporal data was lost. So everything, everywhere, all at once. So this happened across many data centers, across many regions, all at once. Not nice. We heavily use Temporal at DataDog. And some of the things that we do is incident response with Temporal, like processes. So we start to see that after a while, these nodes start to recover, right? But we see that Temporal is showing issues. It's not able to run workflows. If you query a workflow, it's panicking all around, and it's just not able to proceed. This happens because Temporal makes the assumption that you are able to maintain data durability. But we did not. We lost data. So if Temporal now is expecting 10 events in order, 1, 2, 3, 4, 5, and so on, and you lost the number 3, Temporal is like, where's the number 3? Just give it to me. So it will eventually retry, but we have so much data that this retry was basically doing a compounding effect, and it was hugging Temporal too much. So no Temporal API, we lost data, and we need Temporal to help other teams fix their issues during this global incident. So we take the very hard decision to basically do a hard reset. We drop the data in Cassandra. We lose all workflows, all cron jobs, everything. But we regain control over the Temporal API. We value availability over data durability. Hard decision, but at that time it was the right one. So, really hard one to take. Just to give you an idea, and then this is a spectacular image that puts the fear in your heart. This was the incident Zoom call at maybe a couple of hours after it actually happened, and you can see 500 people in a Zoom call of an incident. This is not an all hands. Not good. I was lucky enough to be there, and it was probably one of the best engineering training I've got in my life. So I recommend that you do the same. So, long story short, if you self-host Temporal, you will have to, or potentially, self-host Cassandra, Postgres, or whatever you are using. You will have to self-host your compute, so Kubernetes and so on. Elasticsearch as well. If you are using advanced visibility, you will also have to look into Elasticsearch. And self-hosting Elasticsearch, just like self-hosting Cassandra, is not for the faint of heart. And in addition to that, you have to be aware that this is a changing system. You are not hosting a single version of Temporal, a single version of Elasticsearch. If you do this over a long period of time, you will have to change versions. You will have to migrate your system. You will have to move data around. So you need to be able to operate all of these systems at scale, and probably while they are running. And my colleague Hardy here is going to continue here and talk a little bit more about persistence and operating these systems.
Okay, thank you. My name is Hardy. I'm taking over, and I want to kind of share a couple of more stories now around, in particular, persistence. And I want to start with this premise: persistence is easy. What Marcus described was a once-off incident, like literally whole DataDog went down. But otherwise, you pick your backend, you start the database, and then you're golden. Unfortunately, that's not always the case. Within DataDog, we almost exclusively use Cassandra as a backend for all the good stuff: scalability, availability, fault tolerance, performance. If you're kind of in the business or engineer for long enough, you kind of start immediately wondering, there's always a trade-off, there's always pros and cons. How does Cassandra achieve that? It's a distributed database. Distributed systems are harder to maintain, harder to operate, harder to debug. In the case of this Cassandra, we also need special kind of modeling of the data, which fits the database itself. There you could argue maybe that's Temporal. Now they need to work out the Cassandra schema. But as we will see, it becomes or became also relevant for us that we needed to understand the actual schemas. So the first story I want to share is our migration from Cassandra 3 to 4. So if you read the documentation, it's like, just create a Cassandra cluster, replication factor 3, 4 nodes, you're golden. Yes, if you can stay in this configuration. But if you operate Temporal over a long time, you will need to move data around, run migrations, and so on. So one of our migrations was from Cassandra 3 to 4. And basically, we use Cassandra extensively within DataDog, and the aim was change all Cassandra usage within DataDog from 3 to 4. And Temporal was the last clusters kind of switching from Cassandra 3 to 4. What we had is we had our Temporal clusters. One Temporal cluster would connect to Cassandra. The Cassandra cluster, Cassandra 3 cluster would contain with multiple nodes. And they are what's called in Cassandra like a logical data center. That's a Cassandra term. So we devised this plan. We didn't want to take downtime. We also wanted to make sure we have a lot of long-running workflows. We wanted to get them across as well. So we wanted to do a migration without data loss and without downtime. So this is what we've done. We stood up a Cassandra 4 cluster with its own nodes in its own logical data center. We connected them. That's all Cassandra level things. At that stage, any write to the Cassandra 3 cluster would propagate to Cassandra 4, any new write. What we did not have yet was what's about all the historic data in the Cassandra 3 cluster. So Cassandra has a tool called node tool, and there's a command, the CLI command, node tool build, which you can call to kind of get the historic data from the Cassandra 3 node into the Cassandra 4 nodes. Once this process is complete and you basically have these two clusters connected, conceptually you're good to proceed. The next steps are basically we kept changing the Temporal configuration and kept doing rolling restarts of our Temporal deployment. What we needed to do was also Cassandra details. Per default, we are running in local quorum. if Temporal tries to make a write against the Cassandra database, it's enough to kind of get the write confirmed from one logical DC in local quorum. During the cutover, we wanted to make sure that we have confirmation from both clusters, Cassandra 3 and 4. So we first changed the consistency level from local quorum to each quorum, meaning a write only gets marked as succeeded if we're getting confirmation from both clusters. We did this, we did a rolling restart. After the rolling restart, we changed the configuration again. Now we changed the endpoint to the Cassandra 4 cluster, did a rolling restart, then changed again from each quorum to local quorum, and then we could basically take out the Cassandra 3 cluster. And everything should be fine. As it turned out, it was not. We ran this process for the majority of our fleet, but one of our most important clusters, we basically ran into corrupted history event, batch event is non-contiguous error. And we had initially no idea what was happening. Workflows couldn't make progress, the errors were just appearing, and we did not know how to handle it. So at this stage, now also the data model becomes important or relevant. So we needed to we started to look at the Cassandra database. And there's a history node table in the schema, which basically contains all the events of a given workflow. And the tree ID is basically the same as a run ID. And what we've basically found, it's like we had random rows in this data missing. Could be the first, somewhere in the middle, multiple rows, it depended. So how could that happen? A little bit more Cassandra internals. We also ran, as recommended, with a replication factor of 3, meaning each data is supposed to be replicated to 3 nodes. That is really good, but again, Cassandra is maybe a little bit harder to reason about. In a replication factor of 3, it's enough that 2 nodes acknowledge a write for the write to be fully acknowledged. So a third node doesn't have to respond. There might be network delays or temporary, one node is temporarily not reachable. So in a replication factor of 3, it's actually okay that 2 nodes only respond. As we found out later, so there was another interesting part here is the workflows which got corrupted was not at the time of the cutover. It was workflows were corrupted, they were kind of around 2 months old, and we couldn't figure out why. Using DataDog and our metrics and our historic data, we could go back in time and basically look at the metrics at the time, and we could see that there were network errors to this node at that time. So at this time, some of the writes only persisted to 2 nodes and not to a third one. Cassandra is supposed to recover by itself, so it has mechanisms to kind of make sure the data gets replicated to all 3 nodes, but it's not guaranteed. It can happen that it's not happening. For that, Cassandra offers also the node tool CLI again, and there's a node tool repair, which makes sure that data is properly replicated to all 3 nodes. We had not run that. And as it turned out, that was the cause of our problem. What happened was that one piece is also still missing is when you're running the node tool build to kind of get the historic data from the Cassandra 3 to the Cassandra 4 cluster, node tool build picks a random node out of the Cassandra 3 cluster to pull the data. If it accidentally pulls from the node which did not receive all the data, you're basically ending up on a Cassandra 4 cluster which does not have all data. While the clusters are still joined, all queries still work, because there's always quorum. There's still the Cassandra 3 nodes. There's 2 nodes which can respond to a query. The moment we disconnected the Cassandra 3 cluster, we basically lost data. What did we do? Unfortunately, the Cassandra 3 clusters were run purely in memory, so they were gone. We couldn't recover anything from there. We terminated the workflows, which led us to another full service outage, basically. What happened was if you terminate a workflow, the workflow is still there, it just gets marked as terminated, and then as Markus explained, we use history archival, and there is a bug or behavior in the history archiver which cannot handle a corrupted workflow. So it went into panic, so within a few seconds, basically all our history pods crashed and were in a crash loop. So we had to quickly change the configuration, disable archival, bring our history service back up, and then some other team members kind of went on to kind of patching the history archiver to recover from the panic. So that was also very interesting. And then what we eventually did, we admin deleted the workflows, which is a nice tool to have, which means you literally delete the mutable state out of the database and the workflow is gone. And then we implemented some tooling to be, in case it happens again, so knock on wood, that we can clean up this data more proactively for our users. Now you could argue, we had the full outage, we had the Cassandra 3 to 4 migration. These are all things where it happens, but you usually don't do that so often. Well, let's talk about the Cassandra rolling upgrade. This is an operation we do every week, every second week, just for cluster health, like smaller patches of the Cassandra image needs to be played in, and so on. I can go ahead to this one directly. So what happened there, or what have we seen there? We had the case that in some of our temporal clusters and Cassandra clusters run in the same Kubernetes cluster. So we had the following case. We have T1, temporal instance 1, talking to Cassandra cluster C1, and temporal instance T2 talking to Cassandra instance C2. And each of these Cassandra cluster is in its own Kubernetes namespace, has its own nodes, has its own set of IPs. How the connection between temporal and Cassandra works, there is a GoSQL driver, which it gets a host name and it resolves IP via DNS IP addresses to the nodes in the cluster, and then it can talk to all the nodes in the cluster. So what we did, we triggered a rolling restart at the same time for both Cassandra clusters in this Kubernetes cluster. And what happened was, in the Cassandra cluster 1, one pod went down, it released the IP, and at the same time, a new pod in the Cassandra 2 cluster was coming up, and it got assigned the IP of the pod which just got released. Great, that's going to be fun, right? As you also can see, in yellow there at T1, the GoSQL driver did not have a chance to refresh or kind of catch up on that. It kind of just thought it's still talking to this 10.0.0.4 IP. The schemas are identical, the tables are identical, there is no problem writing for temporal. At the time, we did not have authentication enabled, so basically we had a split brain. We had one temporal instance talking to two different Cassandra databases. And we were actually able to piece that together afterwards by querying Cassandra directly. And remember the list of rows in the event table. Parts of the rows were in one cluster and parts of the rows were in the other cluster. So heaps of fun. But it was too hard trying to recover. So in the end, again, we deleted or terminated, admin deleted these workflows. What did we do to further mitigate? Obviously, authentication. It was maybe a little bit blue-eyed to not run that in the first place. But even there, so we were able to reproduce this incident repeatedly. And the interesting part was that we were even able to, with authentication, get to the same case where we had this cross-writing. It turns out in some Cassandra system tables, some authentication information is stored or cached, and you can cross-write that as well. So you can end up kind of writing the authentication details to the other cluster, and then you still can connect to it from the wrong temporal instance. So on top of authentication, we are enabled Cilium network policies to make sure that only known namespace requests are getting through. So really, the premise that persistence is easy is probably false. That's just a dream. It would be nice, but the reality is it's a long-term operations. If you need to kind of, over a long time, run your data backend or temporal itself, I forgot to mention, this was not the first incident where we had the cross-IP incident. Actually, before the Cassandra cross-IP writing, we had the same thing with Temporal. That's much longer back. At the time, we had 2 Temporal instances in the same Kubernetes cluster, and you might know that Temporal joins a ring pop. It kind of forms its own kind of clustering. And it turned out at the time when we had the incident, if you had 2 Temporal instances in the same Kubernetes cluster, they were joining one ring. So that was another issue with Temporal, which we kind of fixed and upstreamed, and that's not going to happen, but other things can obviously happen. Just very quickly, kind of what are we trying to move forward? We kind of try to build something out based on temporal replication. If you've seen the keynote, it probably sounds very familiar. What we are trying to do is we are taking temporal instances with Cassandra and Elasticsearch. We are connecting them via temporal replication. And the idea is to have a given namespace active always on one cluster, but on standby on another. So A, we try to load balance the namespaces, and B, we want to be able, in case of an incident or in case of problems, to activate this namespace on another cluster. Again, very similar to what we've seen this morning. This is work in progress. We are kind of building this out as we speak. So maybe at another replay, we can talk about our experience with this approach, and if it helps us to avoid or mitigate some of the problems we've just talked about. And other than that, thank you for listening. And if you have any questions.
Okay, there's a couple minutes for questions. If anybody has any, raise your hand. I'll bring the mic to you, right here in the front row.
Thanks very much. I've been sweating through that with you. Yes. I just wonder if you could say something about the sort of key use cases for Temporal at DataDog. I'm assuming it's to do with data pipelines and things.
So use cases, it started off more like an internal tool for infrastructure, like automating anything in engineering, like creating infrastructure, automating processes, all these kind of things. But it's now growing more and more to actually parts of the DataDog products are built on Temporal. But originally, it was more like an internal tool.
Okay, time for one more question, right here.
You showed how you're trying to avoid this in future with HA, but you didn't talk about DR. Why didn't you choose to move to a DR strategy that allows you to recover?
DA?
DR, disaster recovery.
Uh-huh. What do you have in mind there?
To my understanding, you took the decision, we've lost the data, just move on, rather than looking at an architecture where you've got replication in real time that is validated,
right,
and therefore you can recover should the event happen again.
Right. So with Cassandra 3, it was in memory, so we didn't have it on this, so there was no recovery. So the idea was always if you have enough replicas across enough availability zones, you never lose the data, but then with the full DataDog outage, it still happened. The other problem with using Cassandra replication or Postgres replication is it's not on the temporal level. It doesn't help. How do you snapshot? Like you can take a snapshot at a time, but you might take it at the wrong time, so you still have inconsistent data. So if you replay that, or like if you get this snapshot back, you still might have corrupted workflows. So really, in our opinion, the only way to recover in this case is having temporal replication, where replication happens with the knowledge of temporal. Snapshotting any database at regular intervals, it can never be secure. You might kind of snapshot workflows halfway through or something like this, or inconsistent state. So that's why we heavily believe in temporal replication.
In addition to that, if you are running both Cassandra and Elasticsearch, the data in both needs to be consistent. So you need to have the same workflow IDs and so on. So if you want to use Cassandra or Elasticsearch solutions for that, you have to build something to make them work together in exactly the same way.
Okay, well, that takes us to the end of the session. I want you to join me in thanking Hardy and Marcos for such a great presentation.
Thank you.